linear regression. So I will just recap what my previous class. So for those that are unable to join the first class. So yeah, my SPSS data view and theory view here. So I just want to explain some things. Now, yeah, I have name column. I have a column label name here. So I have a label column. So in the column of name, it can only contain 64 characters, and you can't start with numbers. You can start with only alphabets, and there should not be space between the words you want to use. Then you have the type. So your type can be numeric, it can be string, it can be comma. We have a lot of it. But by default, SPSS will give you numeric. So just leave it as numeric like that. Then we have width. Then we have width as well. Then we have decimal. So by default, the decimal will be in two, it will be two decimal places. So you need to change it to 0 decimal place for easy analysis if you want to analyze your data. Then we have label. Now in this label, the usefulness of label is for us to write brief description like what we have denoted in the name. So as I've said earlier, I say my name in the column name, it can contain space or you can start the number. But here in label will give you a chance of writing everything in full. If you can see here, so between my labels, you can see some space here. So which you can use on any spaces in the column of names. Then I have values. Values here is just to decode my data. Let's say for example, if I have categorical data, probably gender now, I have male and female. So in the box of value, you can easily denote, you can easily decode your gender, male to be 1 and your female to be 2. So whenever you are entering your data, you know that okay, once you enter 1, that's for male and 2 is for female. Then we have mixing. So mixing is just for the missing data you have in your observation. So you can just leave that one. Those one will be taken care of in your analysis. Then the most important one we have here again is measure. So for your measure, we have nominal, we have ordinal, and we have scale. So as you have known before, nominal is just a numeric number, like just quantitative variables. Then our ordinal is ordering data, like categorical data. So and scale is just a combination of interval and ratio. So are we together, please? Hello, hello, can you hear me?
Yes, we can hear you.
Okay, thank
Yes,
you.
we can hear you.
So let's move to correlation and regression now. Now, correlation coefficient. What is correlation? Correlation is the process of establishing a relationship or association between two or more variables. And I said correlation coefficient provide a numeric summary of the direction and strength of linear relationship between two variables. Now, what are we using correlation for? It's just to check the strength relationship or association between two or more variables. When you have two variables, at least two variables, just to check the kind of strength or relationship between them. That's what we use correlation for. Then you have Pearson product moment correlation. Now for Pearson product moment correlation, as you can see here, it's used for continuous variable. When we want to use Pearson product correlation, we can only use for continuous variable or one continuous variable and one dichotomous variable. Now, what is dichotomous variable? Dichotomous variable are categorical variables, two variables, male and female, yes and no, high and low. So like that. So that means if you want to perform Pearson product moment correlation, is either we have our variables like two variables to be both continuous, or we have one variable to be continuous while the other will be dichotomous. Then The sign of correlation coefficient indicates the direction of correlation. Now, the ranges for correlation that we can have start from -1 to +1. Now, when you have -1, it tells us that you have negative relationship between two variables. When you have +1, you have perfect positive correlation between two variables. Then we can have 0. That means when you have 0, you have neutral relationship between two variables. Now, how do you perform correlation analysis? Now, when you go to SPSS, as I've said earlier, you can only use either two continuous variables or you use one continuous and one dichotomous variable. Now, the data I have here, I just want to use this for practice, so we can lay our hands on some other data. Now, go to analyze. So you go to bivariate, then you move your independent, like the two variables you want to use. So let's say I want to use age. So I move it there. Then let's say I want to use effective communication too. So I move it here. So you can see I move two variables here. Now, there are some box here. Now, for the first box, when you click on option, the first box you have here is options. So when you click on option, make sure that this exclude KYs pairwise, exclude cases pairwise is marked. Then when you mark it, leave it like that, then you click. Now, you can see here, if you can see my screen here, you have Pearson correlation coefficient, you have Kendall's, then you have Spearman. So if you use any of the three, you actually get the same conclusion. But for tonight, we are using Pearson correlation. Then you have two T or one T. So that you use two T or one T, anyone you like. Then here, if you can check here, you have flag significant correlation. Now, if you use this flag significant correlation, that means you are telling SPSS to use a specific significant level for you. Are you with me? So after that, you click OK. Now, for my analysis here, I have age and the correlation between age and age, which is 1. Then I have correlation between age and effective communication, which is my 0.121. Now, if you check my slide here, result of my analysis, like I have correlation of the analysis here is for sex and effective communication, but let me just explain this. So what I have here, if you check my screen very well, there is correlation between age and age. This is 1. The reason why it is 1 is that there is no way, like any correlation between the same variable must be perfect correlation. So you usually get 1 if you are doing correlation between the same variable. So that's why we have 1 here. Then for the second one, we have age and effective capital, so which is minus 0.121. So this minus 0.121 telling us that we have very fair negative correlation between age and effective capital. Like the relationship between them is very fair and it is negative. Are you getting it, please? The relationship here is very fair and it is negative. Then another thing we have here is n. This n is the number of our non-missing values. So here we are using 150 observations. So the 150 here is the number of our non-missing values. That means we have the complete 150 observations here. So then I'll check my slide here. So that's I have correlation between age and effective capital now. And as I said earlier, my correlation between them is minus 0.121. Minus 0.121. So which is this? And the number of values is 150. Now I have correlation between age and age, which is 1. Now the correlation of the main diagonal are equal to 1 because a variable is always perfect correlated with itself. Any variable that you have and it is correlating with itself, definitely it will give you perfect correlation. Then I made mention of flag significant correlation. Now here, if you have opted for flag significant correlation, SPSS will mark a 0.05 with one asterisk and 0.01 level of significance with two asterisks. Now, this is what it's saying. Now, when you have private data, it's just because this is just normal data. This is not a private data for correlation. Now, here in your significance column here, there are sometimes that when you do the analysis, there are sometimes that you see one asterisk and there are sometimes that you see two asterisks. Now, when you have one asterisk, it's telling you that SPSS has used 0.05 for your level of significance. And if you see two asterisks, telling you that SPSS has used 0.01 as your level of significance. Now, decision and conclusion. From the result, what is our decision and conclusion? We can say H and effective capital have a statistically significant linear relationship. Like they have statistically significant linear relationship. Like there is a relationship between them, but it is negative. Now, another one, the ratio of the relationship is negative because we have minus 0.121. So it is negative. Now, when the relationship like that is negative, now when you are correlating between, when you want to do correlation between two variables, now if you have positive value for your correlation, that means the two variables are increasing. The first variable is increasing, the second variable is increasing. But when you have negative values as your value of the correlation, that means one variable is increasing while the other variable is decreasing. Now, the magnitude or strength of the association is very low because of minus 0.121. It is very low to explain the kind of relationship between two variables, but it's just negative correlation. Do you have any question, please? Hello? Hmm? Please unmute yourself if you want to ask any question, please. Now, the next slide here is linear regression. Now, linear regression, I'm talking about linear regression. So, linear regression, we actually have two types of linear regression. So, you have simple linear regression, and multiple linear regression. So, we have simple linear regression and multiple linear regression. Now, simple linear regression determines the relationship between a single independent variable and dependent variable. Now, before you can perform regression, you must have two things, which is dependent variable, your output, and your independent variables. Now, if you want to perform a simple linear regression, you will have just one independent variables and one dependent variable. But if you want to perform multiple linear regression, you have one dependent variable and at least two independent variables. Are you getting it? Like for the simple linear regression, we must have one dependent variable and one independent variable. But for the multiple linear regression, you must have at least one dependent variable and at least two independent variables. Now, how do you know your dependent and independent variables? Now, let's take for an example. You have a situation where you have blood pressure. Now, blood pressure, you have age. Now, you want to know your independent and dependent variable. You know, it is very, very unrare for you to see a child, probably a child of 10, 12 years, having high blood pressure. You know, it's very rare. But you can only see an old person like 60, 70 above having blood pressure. That means their age. Their age determines the blood pressure. So in this situation, your age is independent variable, while the blood pressure is dependent variable. Are you getting it? So let's move on. Now, for me, I have multiple linear regression determine the relationship between two or more independent variables and the equivalent dependent variables. Now, the independent variable can either be categorical or continuous. Now, they say if you want to do multiple linear regression, your independent variable can be either categorical or continuous. Now, what is categorical data and what is continuous data? Continuous data is just normal data, that's counting data. let's say you have weight, your height. So those are the example of continuous data. But when I'm talking about categorical data, it can just be like example of the levels of students in tertiary institution. So you have 100 level, you have 200 level, you have 300, 400. So those are the categorical data. They have been categorized into each levels. Age, like gender and male and female, they are also categorical data. So we are not saying that if you want to perform multiple linear regression, you can either use categorical data or continuous data for your independent variable. But your dependent variable must be continuous data. Your dependent variable cannot be categorical data. Now, multiple regression includes a family of techniques that can be used to explore the relationship between one continuous dependent variable and number of independent variables or predictors. Now, multiple regression can be used to address questions such as, now, why do we use multiple regression? In what scenario do we use multiple regression? Now, one, how well a set of variables is able to predict a particular outcome. Now, when you have your dependent variables and you have independent variables, now you can use multiple regression to determine how well a variables, like out of the independent variables, how well are they, like how well can they predict the outcome of our dependent variable. Our dependent variable is the output. Now, how well can those independent variables predict our outcomes? That's one first scenario. The second scenario is, which variable in a set of variables is the best predictor of an outcome. Now you have multiple regression. You have let's say you have blood pressure, solely blood pressure for your dependent variable. You have age, you have sex, you have weight, you have height for your independent variable. Now, what the second option is saying that which of those independent variables can predict, can give you the accurate result, can give you the accurate prediction about your dependent variable. It's just like you want to conduct a test for a set of students. Now you have 5 students and you want to conduct a test for them. It is a must that one student will pass than the other students. So now this case is telling us that out of our independent variables, which one can predict, can give us the best and accurate answer, can give us the best and accurate prediction about our dependent variables. Now for the third options, whether a particular predictor variable is still able to predict an outcome when the effect of another variable are controlled for. To predict if a particular variable can give us accurate answer when the other variable are being controlled of. Now, what's the meaning of control of? Now, when you have a dependent variable and you have like 3 independent variables, now you can partially control for 2 independent variables. Like independent variable, then you now be using one independent variables and the dependent variable. Now you want to know that if you take care of those remaining 2 independent variables and use only one independent variable, will it give us accurate prediction that we want? Like, multiple linear regression can be used to determine if a variable out of the independent variables we have can be used, like a single independent variable can be used to predict the dependent variable we want. Like, can it give us accurate answer of the dependent variable if the other independent variable have been taken care of? So next on my slide here is continuation of multiple linear regression. Now for multiple linear regression, we have standard multiple linear regression. This standard multiple linear regression is the one that's most commonly used by people. So generally, it is the most commonly used by people. Now, this is the most commonly used multiple linear regression analysis. All the independent variables are entered into equations simultaneously. Now, what's the meaning of this? Like, all your independent variables, once you have your dependent variables, then all the remaining dependent, probably you want to use 4 or 5 independent variables. All the independent variables will be entering one by one. They will be entering simultaneously. Each independent variable is evaluated in terms of its predictive power. This approach will also tell you how much unique variance in the dependent you check the result, you check how accurate it is. Then you enter the next independent variable. So it's make us to know the most the independent variable that give us the accurate predictions. Now, how do we perform multiple linear regression? If you want to perform multiple linear regression, now the first thing is go to your SPSS. Now go to your SPSS, click on analyze. So come down. When you click on analyze, come down, you will see regression. Hello, what is it? Hello, can you speak louder? Now move your dependent variable and you move your independent variables. Now, if you want to use one dependent variable, let's say I want to make use of age as my dependent variable. Now, I want to make use of effective capital and the security here for my independent variables. Now, if you check my slide,
Cancel
what do you say?
your
I
screen.
can't see your screen.
I can't.
You are working on it. So, can you see it now?
No. Okay.
Okay, can you see? Okay, it's network. Can you see my screen now? I think it should be showing by now. Network issue. So, I've written down all the steps you need to take to perform multiple linear regression. Now, the first step, I say click on analyze. So, after regression, we want to perform. Can you see my screen? So, I say you move to analyze. This is analyze. Then after analyze, you move to regression.
I can't see your screen. I can't see your screen.
So what we want to perform is network. Is network. Can you see it now? It's
Yes.
network issue. Linear regression. Then you click linear regression here. So when you click on linear regression,
I
one
can't
box
see
will
it.
pop
I
up.
can't see it. Let me.
So one box will pop up. So one box will pop up. Now you see independent box, then you see dependent box. Then you move your dependent variables to dependent box, and you move your independent variable to independent box. Now you go to statistics. When you click on statistics, so you have to tick on your estimate is there, leave it. Model fit is there, leave it. Click on descriptives. Click on part and partial correlation. Click on collinearity diagnostics. Then click on R squared change. So also click on WRC. So when you tick all these 7, then you click continue. So after that, you move to plot. So when you move to plot, your set preside move it to Y. Then your set parent move it to X. Then you click on continue. So for the save, you don't need to click on anything, then leave it. Then for the options, you don't need to click on anything, then leave it as well. Then you click OK. So when you click OK, you have the result here. Now, from here, what we have from our results, if you check the output of our result here, so the first thing we have is descriptive statistics. So when you check our output here, the first thing to have here is descriptive statistics. Now, what is the descriptive statistics telling us? Just our normal description of the output, the outcomes. So we have our mean, we have standard deviation, we have n. Now mean here is just telling us the average of each variables. Then we have our standard deviation as well, and we have n, which is the number of variables we have used. Then the next table here is the correlation table. The next table here is the correlation table. So after correlation table, we have variable entered or removed. Then we have model summary. We have ANOVA table. We have coefficients. So we have residual. We have scatter plots as well. Now, I'll explain it one by one. Now, if you check my slide here, I said from the model summary, I have R. Now, what is R? R is the Pearson correlation coefficient, which describes the strength and direction of linear relationship between two or more variables. Like our R, the value of R tells us the kind of relationship we have between two or more variables. Now, what is the value of our R here? Okay, the value of our R here is 0.171. 0.171. So if you check here, I have 0.171. So this is 0.171. It's telling me that there is very low. Is very low. That is very low and positive correlation. This is used to measure the goodness of it or the explanatory power of a model. Now, technically, R square gives the proportion or percentage of the total variation in the dependent variable that is explained by the independent variables. Now, what is R square? R square is telling us here is that our R square can be used to explain how many, like to explain the percentage of which an independent variable has explained our dependent variable. Now, if you check my table here, for my output, the value of my R squared is 0.029. 0.029. Now, to interpret that one, you have to convert your 0.029 to percentage. So for me, my 0.029. So my 0.029 will be 2.9. So the half square value of 0.029 shows that about just 2.9 percentage changes independent variables is explained by independent variables jointly. Now, what is this telling us? We have two independent variables and one dependent variable. Now, the value of this R squared, which is 0.029, is telling us that the two independent variables we have here is explaining just like the two independent variables we have here 99% of the dependent. So while the remaining part, check here the output as well. You have the error part. So you have standard error estimate, which is 0.668. Now, if you convert this 0.668, you'll be having 66.8%. You have 66.8%, which is telling us that has explained just 2.9% of the dependent variables, and we have 68.8% to be our value for the standard error term. That means the larger part, the greater part of about 66.8% is captured by the error terms. This shows that the model has a profit. Now, you see some scenario that the total of your R squared and the standard error will give you 100. When you have a perfect data, the total of your R squared and the error will give you 100. But in some cases, they might not give you 100. In this situation like this, if you add 2.9 and 66.8, you don't have 100. Now, what this is telling us that our independent variables, the two independent variables we have, just explain about 2.9% of the dependent variables, while the larger part, which is 66.8%, has been captured by the error term. This shows that the model has a profit. Why does it have a profit? Had it been our R squared here is above 50% or 50% and above, so we will have said it has a good fit. But since our R squared here is just 2.9, it is very, very low. So once it is below 50%, that means it has a profit. It explains less about our dependent variable. Now, another thing we have here is W-Watson. Now, W-Watson statistics measure the evidence of autocorrelation in the residual. The acceptable W-Watson range of no autocorrelation is between 1.45 and 2.44. Now, what is W-Watson? W-Watson is used to detect whether there is an autocorrelation between the variable. Like in our model, W-Watson can be used to determine if there is autocorrelation in our model. Now, what is that autocorrelation? Now, I said autocorrelation is the degree of correlation between values of the same variables. When we have value of the same variables, the correlation between them is what we call autocorrelation. And I said the acceptable range of the presence of autocorrelation, the acceptable range of no autocorrelation is between 1.25 and 2.44. That means if you have any value outside this range, that means there is autocorrelation in the model. But if any value you have is between this range, like this 1.45 and 2.44, that means there is no evidence of autocorrelation. Now, let's check our output. What do we have? Now, this is our W-Watson. Now, you see here, our W-Watson value is 2.000, which means this 2.000 lies between this 1.45 and 2.44. That means our model, there is no evidence of autocorrelation in our model. So, from the value of W-Watson we have here, that means telling us that there is no evidence of autocorrelation in our model. Thus, the fitted regression line result showed that there is no evidence of autocorrelation as indicated by W-Watson. When you have your value that lies between 1.45 and 2.44, they are in violation. But if you have a value that
Hello, what is happening? Hello.
It's probably network issues.
We can just end the meeting since the network is not okay.
Hello. So I want us to ask question